Okay, so let's work on to find the point that partitions the directed line segment CD in a ratio of 3 to 1. So the first thing I want to do is kind of just briefly jot down where these points are and kind of estimate where I think that the partitioning point is going to be. So this is my point for C, and then 1710 is my point for D. Okay, and if I want to partition it, obviously this is a straight line, so counting it wouldn't be that difficult. But let's talk about a 3 to 1 ratio. If it's 3 to 1, how many total parts do you have? Well, the way to find the total parts is you add 3 plus 1 will give me 4 total parts. So we can count and see how many total pieces that we have within CD, and that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pieces. And if there's 12 total pieces, then how many, and I need 4 parts, I'm trying to ask this in a correct way. I need 4 parts and 12 pieces. So think about saying if I have 12 pieces of a chocolate bar divided amongst 4 friends, how many pieces does each friend get? And the answer to that is 3 pieces. So every 3 squares, 2, 3, would be a piece of your chocolate bar. I think there's more than that though. So let's see, 1, 2, 3. I should definitely have 12 pieces, but it looks like I might have graphed wrong. Yes, I went 1 too many, so D should actually be on this point. There we go. All right, so there's 4 total parts, and I need a 3 to 1 ratio. So I need 3 pieces to 1. So that's going to be this point right here, because there's 1, 2, 3 pieces, and only 1 piece on the right side. So what is that point? That point is 1410. So that's the point that I think partitions the directed line segment in a 3 to 1 ratio. But let's see what happens when we actually plug it into the formula. So if it says CD, the first letter is going to be the one that tells you what your x1 and your y1 is. So the first letter is going to tell me x1, y1. So C is first. D is the ending point because it's the second letter, so he's second. So that's going to be your x2, y2. Ratios are always written A to B. So 3 to 1 is A is 3 and B is 1. So ratios are always written A to B. From here, I have everything that I need for the formula. So I'm going to rewrite this very long, scary looking formula, but it's really not that bad. So x1 plus A over A plus B, x2 minus x1, comma, y1 plus A over A plus B, y2 minus y1. All right, so x1 is 5. Let's change colors. 5 plus A, we said, was 3. A plus B is 3 plus 1. x2 is 17 minus x1 is 5. Okay, y1 is 10. Okay, plus A plus B again, so 3 over 3 plus 1. That doesn't change for your x and your y values. And then y2 is 10 minus 10. Okay, so from here, I'm just going to simplify what I know. So 5 over 3 over 4, and 17 minus 5 is 12. Okay, 10 plus 3 over 4, that's supposed to look like a 3 over 4, times 0. So 3 times 12 is 36, divided by 4 is 9. So 5 plus 9, 10, 3 over 4 times 0, anything times 0 is just 0. So this point ends up being 1410, which is what we thought when we graphed it. And the reason that it wasn't too difficult to decide where the point was graphically was because this is a horizontal line. So how would we predict if our line was diagonal? That might be a little more tricky, but we can always use the idea of we're taking a portion of our total distance and then adding that to the starting point. All right, let's look at another one. So it says partition the point P in the directed line segment X, Y. So X is number 1, he's my first point, X1, Y1, and Y is number 2. And it's a ratio of 1 to 2. So all I need to do is make sure that I identify what my pieces are. My A is 1, my B is 2, and I'm ready to substitute in the values. So x1 is 2 plus 1 over 1 plus 2 times x2 minus x1, comma, y1, because that's my starting y value, plus 1 over 1 plus 2 times y2 minus y1. Okay, so this ends up looking like 2 plus 1 over 3 times 6, comma, 5 plus 1 over 3 times 9. It certainly is fun when we have a fraction of a number that's actually a whole number. So what I mean by that is 2. 1/3 of 6 is 2. So it gives me a nice even number. 5, 1/3 of 9 is 3. Again, I like whole numbers, that's nice. And then this becomes 4, 8. And what I can do is I can verify the total distance, and I can verify how each piece represents that total portion. So I'm going to do the distance formula for every one of these points. So I want to see what the total distance is for x, y. And then I want to see what the total distance is, let's call this point P, for xp and then py. And I'm doing that because I want to show you that there is a ratio that can be calculated from that. So we know the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so the total distance between x and y, it doesn't matter which one you choose for the distance formula, which one is your x1, your y1, and your x2 and your y2. So I'm going to substitute values in for x1, x2. I'm going to keep what I already have written. So that's going to be 8 minus 2 squared plus 14 minus 5 squared. That ends up being the square root of 6 squared plus 9 squared, which is the square root of 36 plus 81, which ultimately gives me the square root of 113, which is approximately 10.8. All right, so now I have x, y, so that's the total amount of distance between them. So for xp this time, I'm going to choose different points to be x1, y1, and x2, y2. So my x value is 2, 5, and my p is 4, 8. Okay, calculating the distance, I'm just going to choose one to be x1, y1, one to be x2, y2. And I have equals, the distance equals the square root of x2 minus x1 squared, so 4 minus 2 squared, plus 8 minus 5 squared. And that ends up being 2 squared plus 3 squared, which is 4 plus 9, square root of 13. And the square root of 13, using my calculator, gives me 3.6. Okay, 3.6. All right, and then I'm going to do the same thing for py. So p again is 4, 8. Y is 8, 14. Plugging it into the distance formula, I'm going to let one x1 be x1, y1, one be x2, y2. So the distance is the square root of x2 minus x1 squared, so 8 minus 4 squared, plus 14 minus 8 squared, which equals the square root of 4 squared plus 6 squared, which equals the square root of 16 plus 36. 16 plus 36 is ultimately square root of 52. The square root of 52 is 7.2. So I kind of want to talk about that 1 to 2 ratio. So if it's 3.6 is the distance between the x and the p. So if I kind of draw this, let's see if we can visualize this. We have x, we have y, and p should be somewhere so that it's 1 to 2. If the distance between x and p is 3.6, and the distance between p and y is 7.2, is that a 1 to 2 ratio? So 3.6 to 7.2, because 3.6 is half of 7.2, or 7.2 is double 3.6, this is a 1 to 2 ratio, which verifies that, that P partitions in a 1 to 2 ratio.